energy savings up to 3% is possible in textile mill ring frames by reducing the energy losses in the intermediate power transmission from between the ring frame main motor to the spindles. Let us go in depth. The energy losses in between the main motor to the spindle, we can see the ring frames consume almost half the mill's monthly electricity bills, and you can save around 2 to 3% of the running frames electricity consumption, around say 2% of the mill's monthly electricity bill. Normally the textile mills record a relative condition monitoring, KWH monitoring of the ring frame for the DOF study. For the same count, around 10% variation is there either in the units or in the UKG or in the kg productivity per frame asset. One of the major reasons of this excess power consumption in a ring frame is that the tin roller bearings and the jockey pulleys in total, they consume excess power in between. The grease in the tin roller bearing after a few months gets dried as a hot cake and hence consumes more power, and maintenance team pumps extra grease routinely on this tin roller bearing. You can say in 8 out of the 10 mills, after greasing exercise done in a ring frame, it trips a few times during restart, and due to over greasing and after repeated attempts of restarting only, the ring frame comes to normal action. Thanks to the Citra case study on the energy consumption breakup of the ring frame, you can see out of the 100% power that is given by the ring frame main motor, almost spindle driving power is around 40% and the spinning power is 20%, whereas the tin roller pulley and shaft that consumes around 12%. Then comes the motor on the chain around 8%. So we are concentrating more on the tin roller pulley and shaft and how this intermediate power transmission can be addressed to now. Ring frame is a unique machine where the motor power is transmitted via 52 tin roller bearings and etc. like jockey pulley and spindle tape up to the spindles in a 1200 spindle frame, for example. Why it is unique means the motor is at one end of the machine and almost the tin roller shaft is almost, let us say, around 150 feet length, and the power is transmitted to say around 1200 spindles only through the tin roller shaft, through the bearings and other accessories. So the power is transmitted to the tin roller shaft first and it consumes 12%, and then only it delivers to all the individual spindle rack of 24 spindles. So on any power distribution network, the universal law is that of the T&D losses, transmission and distribution losses, distribution loss is much more than the transmission loss. Normally distribution loss, I say if it is around 20%, the national T&D loss, 15% goes towards the distribution and 5% goes towards the transmission. Like that in the ring frame also, the distribution of power from the tin roller shaft to the spindles, this is where the excess consumption is there, power consumption is there, that is he is addressed here. So replace with a specialty grease in the motor bearing, tin roller bearing, jockey pulley bearings, and during the overhauling of the machine, this costs very less and the payback is only few months. Why we are talking about the grease that is applied to the motor bearings as well as to the tin roller bearings? You can see the condition of the grease removed from our bearings. There are three stages of grease. The first one is the new grease, good grease quality, and the second is heavily oxidized grease, and the third one is a worn out grease where the thickener and the additive have totally decomposed and the oil has broken down. See, basically grease is a precise combination of additives, oil and thickener. This grease is acting like a sponge to retain and release the oil in the place of friction so as to smoothen the surfaces. Time and temperature conditions can deplete the oil release properties, and when this occurs, the grease gets automatically worn out. we can see the multi-purpose grease what we are using on our 24/7 ring frame and other machines. This needs to be monitored, and it is a high time the mill needs to go for specialty greasing. Many of the textile groups have already changed over to the specialty greasing, but I am addressing to the MSME category of the textile spinning mill segment as well now. The benefits of polyurea thickened multi-complex lithium grease, especially in the ring frame, compared to the conventional multi-purpose greasing. It has an excellent high temperature long life lubrication and a very good pumpability, that is more important here. And the most important thing is the outstanding shear stability or the mechanical stability, that is the focus point here. From the ring frame motor to the tin roller shaft running for 150 feet length, this needs to withstand the tangential shear stress from the motor bearing to the tin roller shaft bearing and the shear stress application. This grease needs to withstand that, and it needs to have excellent corrosion resistance and excellent oil bleed characteristics. This is also more important to have a sustainable working of the greasing in the given application. Increased compatibility with the most conventional lithium complex greases, and it is very much compatible now. We can see, thanks to the study at Salona Carspin Coimbatore, 45 NPPB, this is the tin roller bearing that is used in all the machines, ring frame machines, and after cleaning this tin roller bearing and after removing the hard grease, you can see the volume of hard cake that is removed from the bearing. So, flushing out the grease cake, hardened grease cake is more important, it is a must, and this can only allow the new specialty grease to come inside the bearing. So, consult with the grease OEM and first flush out the in situ bearing grease with the right solvent, and the result of repeated pumping and re-greasing of multi-purpose MP3, we call it as conventional grease, this will definitely damage the bearing life as well as the excess power consumption also in all the bearings. Tin roller system, the self consumption almost during the transmission is around 12%, that is thanks to the Citra study. But this 12% is consumed here first, and then only it allows to the other 24 spindle rack of say, let us say on 1250 numbers of spindle rack it has been used. The root cause of the problem is that the tin roller bearing comes to our mill with the factory sealed multi-purpose grease in the olden days. Hope it is changed now. It has been updated now to the specialty greasing now. Further to it, the mill had re-greased the same multi-purpose grease once in 6 months or 3 months, and more has been pumped all these years on this ring frame tin roller bearing. And we have not removed the old grease from the drain plug. Whether the new grease is in and the old grease is out, the drain grease color will definitely prompt the maintenance team. This needs to be verified or confirmed. The specialty re-greasing interval can be extended minimum of 1 year or more instead of this 3 or 6 month interval online re-greasing interval for the ordinary grease. That is also a time saving for the labor working on this changing or the greasing schedules. A typical ring frame input output parameters, power parameters during the DOF cycle trend recording, you can see the top green line is the speed from 1300 empty DOF to full DOF, almost 20,000 RPM. Middle blue line is the kilowatt, you can see the jerk in kilowatt during the running of the DOF cycle, and the hang length, and you can see on the bottom line, red line. So, thanks to the Honeybee automation format, that is trend is taken from a textile mill when we are doing the energy audits. So, this showcases the friction loss is more between the main motor to the tin roller to the spindles. This is the point to be addressed here. Excess lubrication causes can be prevented from now on by condition based monitoring. So, the mills ignored the tin roller bearing and jockey pulley greasing since many years, and the mills made up its mind to replace the tin roller bearings once in 8 to 10 years. Somewhere it's they say, the group say 6 years, somewhere they say it's around 10 years. But till the 8th year, the mill could not take out the tin roller bearings to overhaul the same and put it back. They were continuously greasing and regreasing only on the same bearing that is kept in that place. On every regreasing of the specialty grease every year for 2 years, please see that old grease needs to be oozed out of the drain plug completely, that is more important. And then only this can only confirm the new grease is taking the old grease position within the bearing. The power transmission losses from the ring frame motor to the spindle. So, you can see the energy loss due to poor lubrication in all the subsystems, right from the main motor to the tin roller bearings to the jockey pulley to the spindle tape and to the spindle. You can see the power given to the 1200 spindle ring frame main motor, let us say it is a 55 kilowatt motor, power transmitted from the motor to the tin roller shaft and from the tin roller shaft to the 52 numbers of 45 NPPB bearings and jockey pulleys, and from there it comes to the package, drafting and spindle drive and spindles. So, the power transmitted from the 52 bearings through the spindle tape to the spinning driving power, this is around 2 to 3% excess power is consumed, the energy loss is happening. This can be addressed now. So, the power ultimately transmitted from the drive to the 1200 spindles. The general guidelines to be followed in the mill is right lubrication at the right time based on condition based monitoring of any given internals of the machine or motor. This only can yield tangible and intangible results. Tangible in the sense power consumption reduces gradually and it sustains, this is more important. Intangible benefit is the machine sustains its rated efficiency at the smooth loading of the during the job cycles. Basically, a textile spinning mill is an alignment oriented industry and many of your motors are all tangentially coupled only to the machines. So, of all the machines, ring frame is very much unique. With one set of spare bearings to start with, the mill can be shocked. It will be shocked on replacing the one set of total tin roller bearings for a given ring frame. Almost 3 to 4% you can see the energy loss that was happening before over the 8 years that had been curtailed or controlled now. It has come down now, it has reduced now. The mill can keep one set of spare tin roller bearing set already pre-greased in the mill with specialty greasing and replaced with the running bearings during one day overall maintenance period. A typical motor OEM, say Balder, they give a longer time interval for regreasing with their Poly-urea EM grease. It is again a polyurea thickened lithium complex grease. It is an excellent grease for all the electrical motors, and especially on a 24/7. If you are using a conventional MP3 grease, that gets caked on these 24/7 motor runnings. Like a specialty greasing to the motor, the mill can discuss with the lubrication expert OEM, especially to the textile specific lubrication expert OEM, to focus on the tin roller bearings and the jockey pulley greasing and achieve better results. New greasing can increase the time interval between the regreasing and the energy saving is achieved in between. So, what is the takeaway from the ring frame specialty greasing is we understand the bearing removal is cumbersome, but the mill can discuss with the textile specific lubrication OEM to first clear out the cake, hard cake inside the bearing with the right solvent timely. This is more important. If once it is done only, then only the old hard cake is removed and that acting like a load that is removed and you can pump in the new grease. This is not only this application is not only applicable to the ring frame, but this polyurea thickened multi-purpose lithium complex grease is very much required for all the 24/7 working machines or motors and all the electrical motors in the industry. Over greasing and repeat regreasing without draining, this acts as a load to the main motors now. Specialty greasing will increase the life of the spindle tape due to less friction. Also, with smooth ramping of spindle speed, the increase in power will not be jerky during the job cycle and smooth variation in kilowatt and kilowatt reduction is seen. We can aim for a higher production after switching over to the specialty grease. Bureau of Energy Efficiency always guides us, the energy consumers, the industries, to monitor the energy consumption first so as to target the reduction. Plenty of case studies has been discussed in detail in this energy conservation and management book in the textile in the book, and the link to buy is through the Notion Press. Lot of energy conservation articles are also posted in the LinkedIn postings, and you can go through the link through this. More details, you can view the YouTube video Energy Measure to Save. More on the energy savings and conservation, low hanging fruits that is achievable in the not only in the textile mills, on any industry segment. Sharing the knowledge to save our energy that is commonly available to us. So the energy education is half done in the energy conservation. So please share your energy savings case studies after the implementation, after you are satisfied, for the benefit of others in the industry and for the benefit of the nation. Thank you. Thank you.